Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about APIs, particularly UNIX and POSIX APIs. If you are not subscribed to my channel, please subscribe to my channel and please don't forget to like the video and please don't forget to share the video with your friends. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of UNIX and POSIX APIs. First of all, what is the API? API, that is nothing but application programming interface. So APIs, right? It are functions. APIs are nothing but functions that can be called by user programs to perform system specific functions. So APIs are nothing but a functions. Application programming interfaces are nothing but functions that can be called by user programs to perform system specific functions. For example, assume that I am developing a software for creating a file, deleting a file and maintaining a file. So I am developing a software for that. So if you want to open a file, what you can do means you can call a API. For example, in Unix, to open a file, fopen is a API. To close a file, fclose is a API. Like that. Understanding, guys? Whatever, if you want to do any task related to the system, right, you can use a APIs that are nothing but small functions, right? So these functions allow the user applications to directly manipulate the system objects such as files and processes. I already told you. As a user, as a software developer, if you want your software to make the changes to your system, for example, if you want to create a file, if you want to delete a file, or if you want to create a process, or if you want to delete a process, for each and everything we have APIs. I already told you, for creating a file, create, for opening a file, fopen, for closing a file, fclose, right? Like that. For each and everything we will have APIs. Also, many Unix commands libraries use APIs to perform the actual work advertised. Not only for that, if you want to do any tasks related to the libraries or Unix commands, you can use APIs. For you have to copy the libraries or to delete the library functions. For each and everything we have APIs. Right, you can just call that APIs and it will take care of the task that has to be done. Right? Next. So most Unix systems provide a common set of APIs to perform the following functions. I told you already. For each and everything we have APIs. For example, for what task we have APIs? For a file manipulation, for process creation and control, for inter-process communication. So inter-process communication means for if two processes wants to communicate, then also we have a APIs for to create the signals, right? For to establish the network communication. For each and everything we have APIs. Getting, guys? So most of the Unix systems provide this provide APIs for these features: file manipulation, right? Inter-process communication, process creation, and so on. Right, guys? So, and one more thing, many Unix APIs access their kernel internal resources. Thus, when one of the APIs is invoked by a process, the execution context is switched from user mode to kernel mode. So, in simple words, when you want to use a API, when a user application wants to use a API has to use the kernel resources. That means API has to execute in the kernel mode. So API has to change its mode from user mode to kernel mode. Context switch should happen. See this diagram, right? Application has to execute that API. So when application wants to execute the API should be executed in the kernel mode. There are two modes supported in Unix: kernel mode and the user mode. Whenever the API wants to execute, it has to execute in the kernel mode. Because API has to be executed in the kernel mode only. Why means I will explain now, right? So, and also it uses the kernel resources. Why API should be executed in kernel mode means here, because kernel mode is a protective execution environment. It is a protective execution environment, and that it allows the user process to access kernel data in a restricted manner, because API should be executed in a protective manner. It should be executed in a restricted manner. Why means changes. As a user, I can't do any changes to the APIs, right? As a user, if I'm in a position to make the changes, again it will be right a dangerous thing. It can crash the entire system. That's why it should be protected. API changes should not be done by a user. User, if he is in a position to change the API, means he can crash the whole system. That's why API should be executed in the kernel mode, because it will directly execute with the directly interact with the system, right? That's why when you are executing the API, the execution should be changed from user mode to the kernel mode, and API should be executed in the kernel mode. Getting, guys? And next, what is a user mode then? A user mode is the normal execution context of any user process, right? So it is a normal execution context. It allows the process to access process specific data only, right? For example, I created a process, so that that process will be executed in a user mode, and it is going to access only the data that is for user, not for the system. System related data can't be accessed in the user mode. Only the process specific data can be accessed in the user mode. Hope you are understanding. So once the API is executed from the once the API is executed in the kernel mode, again it can switch back to the user mode. Context switch happens again from kernel mode to the user mode. Getting, guys? So when API execution completes, it can the process can switch back to the user mode from kernel mode, right? It can switch back from kernel mode to the user mode. See the diagram. See, once the execution completes, right, it can switch back to the user mode. Getting, guys? Application can switch back to the user mode. You can see there in the diagram. Hope you are getting, guys. If you have any doubts, please post your doubts in the comment section, right? So why we have to do this context switching? Why we have to jump like this from user mode to kernel mode, again from kernel mode to user mode? Why? This context switching ensures the controlled execution and avoids the damages. As I told you, it avoids the damages. As a user, right? If API executes in kernel mode, I can't be in a position to change the things again, right? So it will safeguard my system. Getting, guys? So in general, calling an API is time consuming. But if you are using API, we have some disadvantages also. Yes, as an advantage, it will avoid the crashing damages. But what are the disadvantages of using API? So in general, main disadvantage is calling an API is time consuming than calling a user function due to context switching, right? Calling a API means context switch should happen from kernel mode to user mode to kernel mode. So this context switching is time consuming. This is the disadvantage of API. So thus, if you are using a time critical application, you should call API only when it's absolutely necessary. Time critical application means what? For example, in missile related software, there if right 1 second 1 second, right, is misfired means missile will lose the control, right? That's why in that type of applications, that is time critical applications, missile applications, you should call this API only when it is absolutely necessary. Getting, guys? Next, so in APIs, what POSIX will have some APIs, and also UNIX will have some APIs. So what are POSIX APIs? So most POSIX APIs are derived from UNIX APIs. UNIX will have some APIs, right? So in the same way, POSIX will have also some APIs, and most of them are derived from the UNIX APIs only. In general, POSIX API users and behaviors are similar to those of UNIX APIs only. POSIX APIs also behaves in the same way as UNIX APIs only. POSIX APIs right? Again, the committee is there for developing the POSIX APIs. They will also develop their own APIs, but most of the APIs are derived from UNIX APIs only, and their behavior also same as the UNIX APIs only. Getting, guys? However, if a user program should define POSIX source or POSIX C source in their programs to enable this POSIX APIs, right? If they want to use this POSIX APIs, programs should use this one of these two statements, POSIX source or POSIX C source. Then only you can use this POSIX APIs. Getting, guys? Next, what is the UNIX and POSIX development environment? Here, this thing is going to tell about what are the headers you have to include if you want to execute these APIs. See here, I already told you, if you want to use POSIX APIs, you have to include that POSIX C source statements, right? Like that. See here, POSIX provides portability at the source level, right? You know that POSIX standards are mainly developed to achieve the portability. This means that you transport your source program to the target machine, compile it with the standard C compiler using conforming headers, and link it with the standard libraries, right? So what I'm trying to say is, here POSIX provides portability at the source level. That means if you want to execute your POSIX program, you can transport your program to the computer, you can compile it with the standard C compiler, and you can use the same C compiler and you can execute your program. What I'm trying to say is, yes, you can use the APIs, right? You can use that APIs in any machine you want. If you have that particular statement, you can use the same C compiler to execute your POSIX, right? POSIX using program, because your program is also C program, right? That's why it's possible. Getting, guys? So your POSIX APIs can be executed in C compiler also. It's possible. You can include this statement and you can use it, right? Some commonly used POSIX.1 and UNIX APIs are declared in unistd.h header. Remember that. So whatever the APIs you are going to use, UNIX or POSIX, all those APIs will be defined in unistd.h header. And if you want to use that API, you have to include this statement, POSIX source or POSIX C source. And most of the POSIX.1, right, POSIX.1b and UNIX API object code is stored in the libc.a and libc.so libraries. For APIs, API is a function, right? For the function, there will be code, right? So all those API code, for each API there will be code, right? That code will be stored in two libraries, especially. Object code means source code of that particular APIs, right? Program of that particular API will be stored in two folders, mainly libc.a and lib.so libraries. Getting, guys? Next, some of the characteristics of APIs. So what are those? See here, many APIs returns an integer value. Whenever the API finishes the execution, it has to tell the operating system that it finished the execution, right? So to tell that, to tell that API is going to return some integer value. For example, whenever the program returns 0, operating system will assume that program executed successfully. In the same way, whatever the API you use, each and every API will return some integer value. Based on that integer value, I can come to know that whether it is executed successfully, whether it is failed, right? We can understand that. So every API returns an integer value which indicates the termination state of their execution. They can terminate properly or they can terminate with the error code also. That is possible. Getting, guys? For example, see, API return -1 to indicate the execution has failed. If a API returns -1, we should understand that the execution has failed. If a execution is failed, then some variable is there. The variable is error number. The error number variable is set within error code. If any error happens, that particular error code should be should be fetched with the error number variable. Then only a user process may call peer error function to print a diagnostic message. Getting, guys? Why we need a diagnostic message means if any error happens, I should tell the user how to correct that error. That's why. Getting, guys? Right? Hope you're understanding. Right? Now we will see that some error status codes that may be assigned to error number by any API that are defined in error number.h header. Hope you're understanding. So, right, for each error there will be a status code. For every error there will be a error code. For each and every error there will be error code. Based on that error code, the diagnostic message, right, will be displayed. So it will tell the user what to do when the error occurs. Now you will see what are the different types of error status code that will be defined in the error number.h header. Hope you are getting, guys, right? So these are all the different types of status codes and their meanings. First one, e-access. So what does it mean? If this code is displayed means you should understand that a process does not have access permission to perform an operation through a API. Getting, guys? So user will understand that so this process doesn't have any access permission. So he will do whatever he want to make it work, right? Next, EPRM. So what does the meaning of this error code? API was aborted because the calling process does not have the super user privilege. So you don't have this proper administrative privileges, API was aborted. He has to understand that, right? If this status error code, right, this status error code will be, right, this status error code will be passed on to the standard output, right? Then only it may call the standard error function and gives the particular information, diagnostic message, right? Next, ENOENT, a invalid file name was specified to an API. File name was not correct. Next, BADF, an API was called with invalid file descriptor. So address was not proper. Next, EINTR, a API execution was aborted due to signal interruption. Due to some interference, API was aborted. Next, E again, API was aborted because some system resource it requested was temporarily unavailable. So resource was not there, that's why API stopped. Again it should call for the resource. Next, ENOMEM, API was aborted because it could not allocate dynamic memory. It was not able to allocate the dynamic memory. That's why error was displayed. EIO, IO error occurred. Input output related error occurred. ePipe, an API attempted to write the data to a pipe which has no reader, right? So when a API attempted to write a data to a pipe which has no reader, this error will, right, displayed. No, don't worry about pipe and message passing techniques. I will explain those things in the upcoming videos. Next, fault, API was passed an invalid address in one of its argument. While passing the arguments, API passed an invalid argument. Next, no execute, API could not execute a program through one of the execute API. API was executive API have some problem, that's why it can't execute the program. Next, child, a process does not have any child process which it can wait on, right? Child process was not there, it was not created, right? That's why this error. Getting, guys, right? Hope you understood the concept. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.